Good morning, guys. Today we are going to start a problems on torsion of shafts. Now, yesterday just we had gone through how to derive your torsional stiffness matrix per element. See, already we have derived Ket is equals to Gj by L, 1 minus 1 minus 1, 1. It is almost similar to your bar element. Here what you have seen in bar, Ae by Le, but now you are seeing Gj by L. Okay. Then if you come to shear stress, how to determine shear stress per element? See, like stress in your bar element, here we are going to determine shear stress. Because here it is the member is subjected to twist. That is, tau is equals to G into nu. That we can write as G into R by L, theta 2 minus theta 1, or you can express in this format, as well as we have one more format, G into R divided by L, minus 1, 1, theta 1, theta 2. Okay. See, both the ways you can explain it. Then what are the parameters, unknown parameters generally? One is J. What is meant by J? Polar moment of inertia. How to determine polar moment of inertia? See, here we are using for shafts. There are two types of shafts are possible. One is called solid shaft and one more is called hollow shaft. When J, if the problem is given solid shaft, use J will be equal to pi to the power 4 by 32. If for hollow shaft is given, use J will be equal to pi into d naught to the power 4 minus di to the power 4 divided by 32. You know what is d is? That solid shaft means diameter of the shaft. D naught di is called outer diameter and inner diameter of the shaft. Apart from this, say what is G here? G is nothing but rigidity modulus of the shaft. Then length, L is nothing but length of the element. Okay. R is called as the radius of the shaft, and angular twist or angular displacement, that is called theta. These are all the unknown parameters generally we come across in the torsion chapter. Now, today we are going with the first problem. What is problem number 1? That is problem number 1 is a solid stepped bar of a circular cross section shown in figure below is subjected to a torque of 1 kilonewton meter at its free end and a torque of 3 kilonewton meter at its change in cross section. Determine the angle of twist and shear stress in the bar, okay, in the shaft or bar. Okay, take Young's modulus E equals to 2 into 10 power 5 Newton per mm square and G is equals to 7 into 10 power Newton per mm square. This is what the stepped bar given. Okay, stepped bar given. First one is 100 mm diameter shaft and one more is a 50 mm, like a stepped bar. Two elements are there, 100 mm and 50 mm. Then one is 3 kilonewton meter is acting at this particular section and 1 kilonewton at say free end. The length of the shaft is 200 mm and length of the one more shaft is 400 mm. That means two diameters are there. One is 100 mm shaft and 50 mm shaft. Similarly, length is 200 mm up to 200 mm, it is 100 mm. After 200 mm up to 400 mm, then it is a 50 mm shaft. What is data given? Say Young's modulus is given. Then your rigidity modulus G is given. The Young's modulus is not required for this problem. Majorly we are concerned only on G. See, apart from this first step, what is first step? See, similar to your previous problems what you solved, always if you model your first, you can consider whatever the continuum is given, make continuum into a finite element model. See how to make it? See here, you should see how many number of elements I can create. If you observe the problem, I can make it two elements, 1 and 2. Now because of this 1 and 2, how many nodes I can locate? 1, 2 and 3. That means 3 nodes can be possible, 1, 2 and 3. So you can directly do it here, otherwise you can write here in a simple manner. There is a 3 noded element. That means I can create for the given continuum 3 nodes, 1, 2 and 3. You can consider direction of x is this. Okay, 3. Now what is that here generally? Generally it is subjected, T1 is the torque, T2 is the torque at this particular point, T3 is the torque at this particular point. Apart from this, theta 1 is this one angular twist, theta 2 is the angular twist and theta 3 is the angular twist. Apart from this, length is given. From here to here, what is the length? 200 mm is the length from here to here, and from here to here the length is 400 mm. Apart from this, if you want, you can write what is the diameter of this. Pi 100 mm is the diameter of the shaft, pi 50 mm is the diameter of the shaft. This is how you can represent. That means how many number of elements now? 2 elements. This is first element, this is second element. This is how you can convert your given model into a simple finite element model. That means finite element model is represented in the form of element and nodes. Now we are represented. That means T1, theta 1, T2, theta 2, T3, theta 3. That means at each node we got it. Okay, similar to your bar element, there we are using F1, Q1, F2, Q2, F3, Q3. Now, what is the parameters here? See, torque and theta is your parameter, field variables. Represent that. That means the variables will be your T1 and theta, represent that. Okay, this is called formulation of finite element model or converting continuum into a finite element model. So, after this first step, next step is, what is the next step? See, similar to your bar element, elemental torsional stiffness matrix. See, here we don't have a stiffness matrix, we call it as torsional stiffness matrix. Almost similar, but torsional stiffness. We add a name called torsional stiffness matrix. What is torsional stiffness matrix for a bar? G into J divided by L, 1 minus 1 minus 1 1. This is your matrix. Now if you take first element, what is first element? KET1 is equals to, what is my formula becomes? G1 J1 divided by L1, 1 minus 1 minus 1 1. What is unknown for here? See, I know what is your G. G is given 7 into 10 power 4. J is not known, but length is known, 200. Then what is the only parameter unknown is J. Now how to calculate J? Because diameter of the shaft is given. How to calculate J? J is equals to pi to the power 4 by 32 pi into 100 to the power 4 divided by 32. Now calculate what is J first. What is J? 100 to the power 4 divided by 32 into shift. Pi is pi. See, answer is 9.817. 9.817 into 10 power 6. 9.81 into 10 power 6. Now calculate it. See, after doing this, now calculate what is your value. Now 7 into 10 power 4 into 9.81 into 10 power 8. Sorry, 10 power not 8, 6 divided by 200. If you calculate, you are going to get 3.43 into 10 power 9. What I will make it? I will keep 10 power 9 outside. I will write inside 3.43 minus 3.43 minus 3.43 plus 3.43. Now it belongs to what? First element. What are the nodes for first element? 1, 2, 1, 2. This is for your first element. Now repeat same thing for second element. Repeat same thing for second element. Now second element. So what is the second element diameter? 50 mm. First calculate pi into 50 to the power 4 divided by 32. Pi into 50 to the power 4 divided by 32. 50 to the power 4 divided by 32. Shift into pi. That is 613.59. Okay, that means 613.59 into 10 power 3. 10 power 3. Now same thing, 7 into 10 power 4 because G is same for both. Then 613.59 into 10 power 3 divided by, what is the length? 400. 1 minus 1 minus 1 1. If you calculate it, you are going to get what is your K82. That is how to calculate into 7 into 10 power 4 divided by 400. You are going to get, see, that is, you are going to get as 10 power 9. 10 power 9 into 0.107. 0.107 minus 0.107 minus 0.107, and one more is 0.10 minus means 0.107. This is what? Element number 2, 3. Element 2, that is nodes of 2, 3, 2, 3. If I need out, you can just check it the answers once. Pi into 50 to the power 4 divided by 32. Yeah. 613.5 and 10 power 3. Yeah. Into 7 into 10 power 4 divided by 400. Yeah. 107.3 and 10 power 6 is there. I had converted into 10 power 9. That is 10 power 9 into 0.107. Now you got it. Now you got two matrices. Now if you observe, this is your first element matrix. This is your second element matrix. Now what is the global star matrix means? See, KT is nothing but what is the global matrix means? How many things? KET of 1 plus KET of 2. That means add both. If you want to add it, you should be written for continuum. How to write it? You have to check number of rows and number of columns. How many number of rows and number of columns? See, if I see 1, 2, 3, 1, 2, that means I can get here 3 nodes are there. At 3 nodes, only one angular twist is there. Each node have an angular twist, that is theta 1, theta 2, theta 3. That means it should be 3 cross 3. Now, how to write it this? Now keep your 10 power 9 common. This is almost similar to your bar element. Number of nodes 1, 2, 3, 1, 2, 3. Now what is the values? First value 1 cross 1. If you observe this is same 3.43. 2 cross 1 minus 3.43. Then 3 cross 1, I think no value is there in both. 3 cross 1 is 0. First row should be equals to first column because of symmetric nature of the matrix, stiffness matrix. Then take your second one 3.43. Now you have 3.43 here, 2, but 2 here also you have. Just add both the values, 3.43 plus 0.107. If you add both, 3.537, then minus 0.107, minus 0.107, just you can check it, you can get it, just already you're done, because of that I'm writing a little bit quicker, then 0.107. Same procedure you adopted even in trusses as well as bars. Okay, you know how to calculate this global stiffness matrix. Why? Because 3 cross 3 is the order of the matrix. The continue consists of 3 nodes. At each node, single angular twist. Each node we have a one angular twist, that will be 3 cross 3. Or this is after, this is how you can formulate your global stiffness, torsional stiffness matrix, global. Then after this global torsional stiffness matrix, next thing is how to determine your global torque vector and angle of twist. If you observe global torque vector and angle of twist, just observe your problem here. See, what is here? Theta 1, theta 2, theta 3 are called angle twist vectors. That means angle twist vector theta is equals to theta 1, theta 2, theta 3, because these are all the unknown parameters we want to calculate. This is just like your Q1, Q2, Q3 in your bar elements. Okay, similar to your bar elements. Okay, then after this, what is next one? Torque vector. Torque vector means here T is equals to what is the torque acting at node 1, what is the torque acting at node 2, and what is the torque acting at node 3. Just observe this. T equals to T1, T2, T3, because only parameter we can substitute, the number is subjected to torque. See, any torque is acting at node 1, just observe your figure. Any torque is acting at node 1, see, it is fixed. There is no torque is acting at node 1. Because of that, what is that value? This is 0. Then take your torque acting at node 2. See, torque acting at node 2 is what? 3 kilonewton meter. What is 3 kilonewton meter means? 3 kilonewton meter. T2 will be equal to what? 3 kilonewton meter. You convert it to millimeter, because I have written all the values in millimeter. 3 into 10 power 3, total 10 power 6 Newton per millimeter, Newton millimeter. That means 3 into 10 power 6. That means what is the value here? 3 into 10 power 6 kilonewton meter. Kilonewton means 10 power 3. Then 1 meter equals to 1000 millimeter. Convert that. It will be totally 3 into 10 power 6. That is at node 2. Similarly, observe node 3. Node 3 have only one value, that is 1 kilonewton meter. Similarly, write it. What is that value? 1 into 10 power 6. Now this is called your torque vector. Now you got, if you observe this, the next one is equilibrium equation for continuum. What is equilibrium equation for continuum? Just like KQ equals to F. Now here is K into theta is equals to T. K now, theta is now, T is now. Now bring all the values here. 10 power 9. What is K values? That here 3.43 minus 3.43 0 minus 3.43 0. Then what is this value? 3.537 minus 0.107 minus 0.107 0.107. Now you got K value, K matrix. Then what is theta? Theta 1, theta 2 and theta 3. Then what is your torque vector? T is equals to, what is the T value? 0, 3 into 10 power 6 and 1 into 10 power 6. This is your matrix. Now after this, what is this? See, after writing K into theta equals to T, your next step is applying boundary condition. If you want to apply boundary condition similar to your bar element, just observe the problem. See, what is it here? It is fixed, correct? Fixed means what? The angular twist at that particular point will be equal to 0. Which node is fixed? See, from figure, node 1 is fixed. What is the meaning of node 1 is fixed? See, node 1 is fixed means that the twist, angular twist at that particular point will be equal to 0. Theta 1 is equals to 0. Like your displacement, here theta 1 will be equal to 0. If theta 1 will be equal to 0, now what is from elimination method? See, we are going to use only elimination method here. Elimination method. What elimination method says? Eliminate corresponding row and corresponding column. Which is a corresponding row for theta 1? First row and first column. Eliminate first row and first column. Eliminate first row and first column. See, if you eliminate first row and first column, then write your remaining values. 10 power 9, 3.537, minus 0.107, minus 0.107, 0.107. Then here, what is our remaining nodes? Theta 2, theta 3, then 3 into 10 power 6, 1 into 10 power 6. See, here I taken what? This directionally positive. That means torque in your anti-clockwise direction I have taken as positive. If you take it clockwise direction, it will be negative. 3 into 10 power 6, 1 into 10 power 6. Or this. Then, see, using your calculator, two equations will be there. If you solve it, you are going to get theta 2 will be equal to, you are going to get theta 2 will be equal to 1.162 into 10 power minus 3 radians, and one more value is 0.0105 radians. This is what the two displays the angular twist you are going to get. One is at node 2, one is at node 3. Just if solve those two equations. See, now we got angular twist. What is the next thing you want to calculate? How to calculate shear stress? Because he is given the problem, determine shear stress and angle of twist. Now angle of twist is calculated. How to calculate shear stress? Now to calculate shear stress, we have the relation G into R by L into minus 1 theta 1 theta 2. This is the formula. Now if you want for first element, use first element. What is the G value for first element? 7 into 10 power 4. That is common. R is nothing but radius of the shaft. What is the diameter given? 100 mm. That means radius means 50. What is the length of the element? 200 mm. Minus 1. What is theta 1? Theta 1 is 0. What is theta 2? 1.162 into 10 power minus 3. If you calculate it, what is the value you are going to get? Just check it. That is 7 into 10 power 4 into 50 divided by 200. Okay, into answer into what is this one? Minus 1 into 0 plus 1 into, that is 1.162 into 10 power minus 3. If you solve it, you are going to get 20.335 Newton per millimeter square is the shear stress acting in shaft 1. Similarly, repeat this toe 2. What is toe 2? 7 in 10 power 4, it is same. But if you take radius, what is the radius of second one? Diameter is 50 mm, radius will be 25. What is the length of the shaft? 400 minus 1 plus 1. What is theta 2? Theta 2 is 1.162 into 10 power minus 3. Theta 3 is 0.0105. Why theta 2, theta 3? Because second element. What is the displacement for second element? Theta 2 and theta 3. Now just check it. Minus 1.162 into 10 power minus 3 plus 0.0105 into 7 into 10 power 4 into 25 divided by 400. The answer you are going to get is 40.85. 40.85. The answer is 40.85 Newton per mm square. This is your second element. This is how you can calculate your solutions for the torsion. Okay, just observe once again. See, it is a problem given. First thing, what is step? FE model, convert FE model. See, after converting FE model, just shift your step 2 is determine your elemental stiffness matrix of torsional elemental stiffness matrix. Determine how you want to determine your KET1, KE2, KET2. Then after that, globalize it. Globalize means that is right for your continuum. Okay, after converting continuum, then determine the global torque vector and angle of twist. After determining those two, now equilibrium equation for continuum. See, after equilibrium equation for continuum, apply your boundary condition. Applied your elimination method. Using elimination method, eliminated the fixed row and column. Okay. After that, now determine your theta 2 and theta 3. That means what are the displacements unknown. Angular twist is unknown. You can calculate that. Then after calculating that, calculate the shear stress. This is called a simple procedure for determining solution for the torsion of bar problem. Torsion of bar problem.